In this lesson, we're going to look at the activity series of the elements, and really all we're doing is we're giving an order of reactivity of the element. So if something is higher on the list, it is more likely to replace something that is lower on the list, and a spontaneous reaction will occur. To get the reactions to occur the other direction, we usually have to add energy to make that happen. So top elements are less stable, and so they will replace elements lower on the series. And with this, we can decide whether or not reactions are going to occur. Most of these reactions we're looking at are single replacement reactions. Some of them are combustion, some of them are acid-base reactions. All of them are redox reactions. So we're looking at whether or not the elements are actually going to exchange electrons. This is pretty straightforward. Here's the activity series of the metals. And you'll notice we've got our alkali metals over here and then our alkaline earth metals, and you start throwing in some transition metals. And so lithium is a very reactive metal, and we go all the way down to gold, which is not very reactive, gold, platinum, silver. So we can see that if we had a reaction with lithium and a copper compound, lithium would replace the copper compound because lithium is higher in the series. Over here we have the halogens. Fluorine is our most active, iodine is our least active, so fluorine would replace anything else in a reaction. So let's just go ahead and jump into some examples. So what we're supposed to do is decide if the reaction would occur. If it will, then we'll complete it and balance it. So this is a single replacement reaction. We need to know, will lithium replace strontium? Well, lithium is higher on the list than strontium. So yes, this will occur, and we will get strontium plus lithium chloride, LiCl. Of course, this would be a solid. This would probably be aqueous, but we've got two chlorines over here, so we need two of these and two of those. So yes, we would get a reaction. Magnesium, on the other hand, is down here, and it is lower than barium, so it's not going to make this replacement. Not going to happen, so no reaction. And then iron and nickel, we can see, well, iron is higher on the list, nickel is lower on the list, so iron will replace nickel with the cyanide, and we should get iron 3 cyanide, perhaps. And then let's take a look at some of the halogen ones. So here I've got my activity series of the halogens. We've got chlorine and magnesium fluoride. Well, chlorine is less active than fluorine. Chlorine is down here. Fluorine's at the top, so nope, we don't expect a reaction here. But fluorine is more reactive than chlorine, so we should expect to get CrF3, and then of course we would need to balance this. We need 2 of these and 3 of these. Oh, and then we would also get our chlorine gas over here, and we get 3 of these and 2 of these. So we would expect that. Bromine would replace iodine. It is higher on the series, so single replacement reaction. You can work that out. And then we need to start looking on these ones on whether or not the reaction will occur. And so that's what this information is telling us. What will these things react with when it's not a replacement reaction? So here we have calcium with water. And it says calcium will react with water, forming hydrogen gas and a hydroxide salt. So we're going to get out of this H2 plus calcium oxide. That's a +2 and a -2, so CaO. And that one's all balanced, so we're good there. Zinc and steam. Well, here's zinc, and it says these will react with steam, forming hydrogen gas and a hydroxide salt. So this would be H2 plus zinc oxide. Zinc is a 2+ ion, so ZNO. So this one's also fairly straightforward reaction. Gold, though, not only will it not react with oxygen, but it also doesn't react with any of this stuff. So gold, nope, this reaction not going to happen, at least not spontaneously. And then we have some of these. These are all acids, right? We got this diprotic acid. We've got hydrosulfuric acid, perchloric acid, and carbonic acid. So this says iron. Iron's right here. It says these metals will react with acids, replacing hydrogen and forming hydrogen gas. So we will get hydrogen gas out of this, H2. And then Fe, we go iron 2 sulfide, FeS, balanced. Tin and perchloric acid. So here's tin down here. It says does not react with water, but it will react with acids, replacing hydrogen and forming hydrogen gas. So tin, 2 chloride probably, so C, or perchlorate, so ClO4, 2. and H2. And we would need 2 of these. And then platinum does not react with oxygen, but it also is lower than these, so it's not going to react with acids, so we get no reaction out of that. So you can use the properties in the table to decide whether or not these reactions will occur. Cadmium is right here. Let's see, CD, bottom of this one. It will react with oxygen, forming an oxide, so this combustion reaction occurs. Silver, Ag, is a fairly active metal. Got to find it on my list right here, but not active enough to react with oxygen. And then we have rubidium, which is all the way at the top. It will react with oxygen, forming rubidium oxide, and you can get Rb2O out of that. And so you would need to balance that reaction. We need 2 of these and 4 of these.